Hello, AWS On Air family. It's Brian, and I'm thrilled to have you here for another exciting episode of AWS On Air. Today, we're going to be talking to the Fault Injection team. Specifically, we're going to be talking about a new feature that's around like introducing cross-region connectivity, AZ availability, and power interruption. It's going to be a cool episode, but before we kick things off, let me have my host introduce himself.
I
James,
can
tell me
introduce
who
myself.
you are.
I'm James Spencer. I'm back once again. I'm a partner solutions architect here at AWS and also one of the hosts of AWS On Air. And I'm happy to be here again at reInvent in Las Vegas.
Yes, and if you're a long-term subscriber or a new viewer, we're excited to have you here. So let's meet our guests. First, let's start with you. Tell them who you are.
Laura Thompson. I'm a product manager with Fault Injection Service.
Awesome, awesome.
Hey, everyone. I'm Serafin. I'm a principal engineer with AWS Fault Injection Service.
All right, cool. So I guess we should talk about what is fault injection.
Yeah, so have you heard of chaos engineering?
I have.
I've heard of it.
So it's something we've been hearing more. It's been getting more and more popular with customers and more common. So we initially built the service for chaos engineering and thinking about learning about the unknowns, discovering things, learning. And the past couple years since we launched the service, we've been thinking a lot more about resilience testing and knowing the availability requirements of your service, things you should be resilient to, and using resilience testing as a way to intentionally inject those faults and demonstrate that your application really can respond the way you expect. And if it doesn't, then you learn something.
Yeah, then you can go in and fix it. And like you just said, one of the things that I like to talk about is you always have your known unknowns and you have your unknown unknowns, those things that you don't know that can break. And one of the ways to do that is by purposely breaking something and making sure that you're able to bounce back. So when it comes to resilience, we have what we call the shared responsibility model here at AWS. I'm sure everyone's heard that about 1,000 times. But how does the Fault Injection Service kind of assist customers and partners with that shared responsibility model and resilience?
Yeah, it's similar to security and other areas where we have that shared responsibility. But for resilience, we think about resilience in the cloud and resilience of the cloud, where AWS is responsible for of the cloud. So thinking about the infrastructure, the software running in the cloud, and making sure that meets the availability requirements that we've committed to with our SLAs. Then there's resilience in the cloud, and that's customers thinking about architecting your application to meet the availability requirements you have based on the criticality of the workload.
Okay. And you mentioned a word, chaos engineering, right? When we think about software engineering, we're always preparing to create great software. We're engineering it to work a certain way. Can you talk a little bit about like the kind of the best practices around chaos engineering?
Do you want to take this one?
Yeah. Again,
no pressure.
Tossing it over.
Yeah. So there's the unknowns, and one of the things that we are focused on is developers tend to focus a lot on system resilience. That's my application can bounce back after there's been an event, right? But there's more to it than that. There's also the aspect of your operators, right? Your people, your processes. So it's taking that into consideration as well to think about more in terms of operational resilience rather than system resilience.
Okay. And then, so when you're doing these tests for your chaos engineering, a lot of times people have to engineer their own tests, their own custom ones every time. And so I think part of what we're going to talk about today is kind of the new feature is templatization and building experiments from building blocks in the Fault Injection Service.
Exactly. So when we launched FIS, we had a set of fault actions that customers could use on their own or combine to make more complex scenarios. But there was a lot of thought and work on the customer side in developing what those scenarios should be for their specific applications. And there was an opportunity for AWS, based on our experience operating applications, running highly resilient services, and starting to define what those scenarios should be for running on your applications. So that was the launch we had earlier today.
Awesome. Yeah, because some of those scenarios are very, very, like we said, templatized. You have single instance impairment, power outages, AZ power outages, region disconnects, those kind of things. And we're able to actually allow you to test your stuff with what we just launched. Do you want to give us a demo? We can dive right in.
Yeah, let's go for it.
Let's take a look at this. I'm super excited about this product because, I've been a dev for a long time, and I was a junior dev, and I was the fault injection. They were like, here it comes. Brian's deploying to production, so we got to get ready for this. So I'm
Which,
glad
if you're still at that phase, you probably shouldn't be doing fault injection.
I grew up, so
Yeah.
I'm glad that happened.
Once your application is stable, then this is a great place to go. So we just a month ago, we launched Scenario Library. So that's where we'll continue to add to this, but they're AWS defined scenarios. These two you see listed first are the ones we launched earlier today. But you see the AZ availability power interruption, and what this one includes is basically the expected symptoms during a power interruption. So it's your zonal compute, EC2, ECS, EKS, stopping the compute that's already running as well as preventing it from reprovisioning.
Yeah. And these other two options too is like stressing EC2, CPU, and disk. This is neat. Very neat.
Yeah. There's a lot of cool stuff in here, and you can, as you click each scenario, you get a little overview of what it is, any prerequisites, show the JSON, so you can always copy it and use another tool if you prefer, and then a bit more detail about what it is, how it works, and then sometimes for the more complex scenarios that affect multiple services, like with the power interruption, we put a lot of detail in the documentation around what customers can expect during a power interruption and how the scenario includes that aspect.
Awesome. And these are just libraries. Like we can also, as we're building, I'm sure we'll get into it a little bit, we can customize those as well, I'm sure, right?
Yeah, so you could remove components or you could add additional.
Yeah.
There's also an action where you can run an SSMA script as part of the experiment. So if there is super custom stuff you want to do, you can bring it into the same experiment and FIS will orchestrate it for you, and you get the safety guardrails that are built in with FIS.
Awesome.
Can you share this like between other users or accounts or anything like this?
So every account has the scenario library with the scenario in it.
Yeah.
And then once you create the template with it, if you do some customizations, you can share the template.
Oh man, that's awesome. Very cool.
We'll demo the power interruption, but while we're here, let's take a look at the connectivity as well.
Yeah. So in this scenario, we sort of disconnect your application in your secondary or recovery region from your primary region, right? So we will block traffic that goes over VPC peering, transit gateway, or internet gateway targeted to the target region. So not all the connectivity towards the internet, but only those that is targeted to AWS in the primary region, right? And we'll also pause S3 cross-region replication and DynamoDB global table replication.
Okay, cool.
Oh, man, this is awesome.
And again, you get the building blocks. So like pausing S3 replication has other use cases besides just this. So you can also use the action.
Oh man.
All right, let's take a look. So we select our scenario, and then we'll go into making a template. So if we were going to use this with an application that spanned multiple accounts, you can target resources in multiple accounts.
Oh, okay, nice.
Here we'll stick with one.
Yeah, because in a real life scenario, most companies and partners are not using a single account.
No, very much a
It's such a common model that
Yeah.
it makes the orchestration so much easier if you can run it in one place. So we have a friendly name and description, and then all these actions and targets are what come from the scenario definition. So the targets are the resources that are being impacted when this experiment runs.
Awesome.
So this little parameters aspects includes the required parameters to run the scenario. So here, the customer will define the AZ to be impacted, and then this also includes an IAM role that would be doing instance provisioning. If you have that, needs to be defined as well. So we can include that, and then some advanced parameters are all populated by the scenario, but we expose them here so they can all be customized if you want. Like the tags, if you have your own, say, application tags, you could put those there.
Got it.
Durations of time. We have some defaults that are pretty typical of what we expect to work for most customers, but again, it can all be customized.
Okay, so when we talk about targeting tags, say we're in that, like I said, that experiment phase. If we're still building out our chaos engineering, and we don't want to break prod, we only want to attack those, or have those ones that are tagged that we're targeting, and see if we're doing the right kind of tests. That's what that is for.
It could be used that way. It could also be like if you had multiple applications running in one account, you could say put an application tag on some of the resources so you can control blast radius that way.
And because we are tightly integrated with IAM fine-grained controls. You can also use those tags to explicitly deny FIS actions on those resources that are tagged with production.
Okay.
For example.
Yeah, very cool.
Cool.
Non-prod is totally where you should start with this as well. Okay, so here's our actions and our targets. So these are all defined by the scenario, and then there's some other cool aspects in the template. So we recently launched this just earlier this week, but around an option to skip an action. And what this does is if you lets you have one template or one type of scenario that can work for different applications that might have different types of resources, different architectures within them. So like this includes ECS and EKS. Maybe you're not using ECS, in which case FIS will go look for ECS with the tags you've provided, and if there's nothing there, then it'll just skip the action but still continue. It just makes it a little bit easier to not have to manage many bespoke templates for your different applications.
Yeah.
And when FIS runs the experiment, we assume an IAM role. You can create your own and specify it there, or in the console, we'll create one for you with the required permissions based on the actions that are in the template.
Oh, wow. That's even easier. Wow.
Yeah, super easy. And then the stop conditions are one of our safety guardrails. So it's an alarm that you specify. And when you run the experiment, you want the alarm to be something you don't expect to go off. And then if it does, FIS will automatically roll back and stop the experiment.
Wow.
It's logs, so when the experiment runs, we put timestamp logs of everything that happens, all the resources that are impacted, what impact they get, and that's all logged there, so you can specify where that goes. And then we can create our template.
Cool.
Yeah, this is awesome. I like it.
All right. Well, we're running down on time a little bit. Did you have? I think we might have mentioned we had something cooking show style to move forward to.
All right, so pie under the counter. Here's our cooking show here.
We've set up a small demo application with EC2 instances distributed in 3 different availability zones behind an elastic load balancer.
Yeah.
And we'll be running the scenario targeting the USD's 1A availability zone. We've also set up canaries using Cloud Synthetics, 3 canaries, 1 per each availability zone, and 1 regional canary that captures the customer experience.
Cool.
Right, so here in the confirmation pop-up, we type start to initiate the experiment. You can see how all the actions are now pending. Right, it takes a few seconds to set up things before we can get going. Here, all the synthetics, all the canaries are fine. You see 1 per AZ, and 1 that is the regional one. Right, all of them are passing 100% success, all good. So if we go back to the target groups of the load balancer, you can see how there's, you can't see, but there's 2 instances in each AC, I promise, and all of them show as healthy. Same for, we have Elastic Cache here. It's 3 AC, the primary, it's in USDis1, and our RDS database has the writer in USDis1. So everything is in USDis1. And there's where we are going to run the experiment. Fail over RDS, already completed. Stop instances. We set up this demo purposefully so that one was skipped, to show that it's skipped. Everything else is running. Now, back to the autoscaling group. Autoscaling already picked up that the instances are unhealthy in USDis 1A. And what it's going to do is going to attempt to provision 2 more instances in one USDis A, but it won't, right? Because it can't, because we are injecting, FIS is injecting insufficient capacity errors to requests made by autoscaling group. The message contains that it's injected by AWS FIS, so that you don't go crazy thinking that this is an actual issue. What happened here is that autoscaling provisioned 2 additional instances, 1 in a different AC, right? So if we go back to the load balancers, you can see now how there's only 4 healthy instances, and the 2 unhealthy instances in USDis 1A are draining, and we are registering the new instances. I'm rushing a bit because we are very short on time.
Yes.
Yeah, that's okay.
Yeah, that's good.
Here you can see how consistently the RDS and Elasticache are now in modifying state, right? So the primary, it's already changed. So it's no longer in USDIS 1A, it's in a different AC, in this case USDIS 1C. And our cloud synthetics for 1A are now failed. Similar for the regional one, because requests that are heading to 1A are now failing.
Awesome. And this all launched today, we said?
Yes.
Awesome.
Yes.
Oh, that's that.
All right. And so if they want to get started, they can just dive into the console, and it's all there. It's all available, ready to go.
It's ready to go.
Cool.
Yep. Anybody can go check it out.
All right. Well, thank you very much.
Thank you for having
Thanks, guys.
Laura and Seraphin, we're glad to be here.
Yeah.
We're glad to be here at reInvent 2023. Stay tuned. We got more stuff coming up right after this.